there's a problem on the AcidBase Foundations that states CH3NH2 is placed in water. So it says CH3NH2 is placed in water. All right. At an angle, sorry. And it wants to know what is the conjugate base that will form. Now, you've got to be real careful on the wording of these conjugate questions, because it can inherently be confusing even if you know what you're doing. Just because it's asking for a conjugate base doesn't mean it's the compound it gave you that's going to produce it, all right? Because it's an interaction with water, so we need to really focus on everything that's going to happen in this Bronsted-Lowry interaction in order to figure this out. There's a lot of other questions on this assignment that just say things like, what's the conjugate acid of so-and-so? And if it says, what's the conjugate acid of so-and-so, well, that so-and-so is being treated as a base in that example, so it would need to gain a proton. So make sure that you're focusing on the wording. Now, if we finish this Bronsted-Lowry interaction, all right, what I can see here is that the given compound is basic. I know it's basic because, look, it's a nitrogenous base. It doesn't start with hydrogen, so it's not jumping at me as an acid, which means my amphoteric water is going to be acting as an acid. Bronsted-Lowry states that acids will donate a proton to the base overall, so I just want to show that change on the other side. So if the base receives a proton, it's going to look like this. All right, you can notice it's this compound with one more hydrogen and one more positive. It was neutral, so now it's an ion. The water lost the proton, so we need to remove an H+, and it's going to be left as hydroxide. All right, H2O with one less H+. Now, remember what we're looking for, though. So altered bases produce conjugate and the opposite species acids. Altered acids in Bronsted-Lowry produce conjugate bases. Therefore, my answer is hydroxide, the OH-.